Every long-lived software system reaches a point where change becomes dangerous. Not because the engineers are bad, not because the tools are outdated, but because the system itself reaches a threshold. Past this point, velocity slows, risk explodes, and every fix creates two new problems. Most teams don't notice when it happens. By the time they do, it's already irreversible. We have more tools than ever, more frameworks, more observability, more automation, and yet we ship slower. We fear deployments, and every simple change feels like defusing a bomb. Given enough time, every enterprise application accumulates technical debt beyond its capacity to service it, because complexity compounds, and humans do not. A predictable pattern. The 6 stages of terminal technical debt. Stage 1, the Greenfield project. In the beginning, the code base is small. The team is senior. The abstractions are clean. Everyone understands the system end to end. Then, growth arrives. Features outpace architecture. Roadmaps outpace refactoring. Revenue validates velocity. Technical debt does not arrive all at once. It arrives as reasonable decisions. A feature flag that will be later removed. A hot fix merged straight into main because production is burning. A dependency isn't updated because the breaking changes are too deep to touch. In isolation, each decision is rational. Together, they form a feedback loop. By the time leadership notices, the damage is already compiled, deployed, and depended on. Stage 2, productive debt. Technical debt begins with a deal. Not a reckless one, a rational one. The language varies. We'll refactor after MVP. This is just temporary. We need to hit the quarter. The result is always the same. Velocity increases. Shortcuts pay dividends. The pressure relief valve opens. Structural liability has been encoded into the foundations. The system accepts the debt immediately. The interest is deferred. The lender is time. This is where debt is incurred, but not felt. The system still responds. Latency is hidden. Errors are rare. Nothing is visibly broken, but the countdown has already begun. Stage 3, compounding debt. Temporary solutions harden into permanent patterns. New features require workarounds. Tests become selective. Refactors are postponed because risk. Each change still looks reasonable. No single commit looks irresponsible. The system still works, but only if you already know its secrets. The code no longer reflects intent. It reflects historic compromise. Engineers stop reasoning with the system and start reasoning around the system. This is where entropy begins to outpace understanding. Stage 4, the scale multiplier. Every enterprise system scales. Not always in traffic, not always in users, not always in throughput, but it always scales somewhere. And scale turns minor defects into major events. Sometimes it's data. A table that holds 1,000 records now holds millions. Sometimes it's scope. One product becomes 3. One workflow becomes 10. Sometimes it's the team. More engineers touch the code. Context fragments. Changes become defensive. This is an inflection point. The system still functions, but small defects now produce large consequences. Once scale amplifies debt, it cannot be unamplified, only paid. Stage 5, organizational deadlock. This is the moment that failure crosses a boundary. It exits the codebase and enters the org chart. Every change requires coordination. Every deployment carries risk. Every estimate becomes a negotiation. This is a race condition in team dynamics. Product demands velocity. Engineers demand stability. Leadership demands both. The result is deadlock. Not theoretical deadlock, operational deadlock. Trust erodes. Trust in estimates, trust in releases, trust between teams. Process is added, not to improve flow, but to manage fear. At this point, everyone knows. Every change introduces regressions. Roadmaps slip. The codebase resists modification. The system is no longer built. It is maintained against entropy. At this stage, technical debt stops being abstract. It becomes organizational drag. This is where technical debt becomes human debt. Senior engineers burn out. Junior engineers stagnate. On-call becomes a lifestyle. Meetings feel like interrogations. Every notification feels urgent. Questions make you defensive. Sleep becomes conditional. Heart rate always racing. And then someone says the words out loud. Stage 6, the false exit. The suggestion finally surfaces. Rewrite, or one of its cousins. Replatform, modernize, move to microservices, go back to monolith, build a clean core. The rewrite is comforting because it offers a story. That the problem is where we are, not how the system evolved. A new codebase promises escape velocity, a reset of entropy, a chance to do it right this time. For a while, it works. Velocity returns, morale improves, architectural diagrams look clean, but nothing fundamentally has changed. The same incentives still apply. The same roadmap pressure exists. The same edge cases must be supported. So the same trade-offs are made. The shortcuts reappear, the temporary decisions harden, the exceptions accumulate. Only now it's written in a new language, with a new framework, and fewer people remember why the old system failed. If you split a monolith into services, you trade internal complexity for operational complexity. If you collapse services into a monolith, you trade network failures for coordination failures. If you rewrite from scratch, you inherit the business rules, but lose the scars that taught you where they break. Nothing is removed. The debt does not disappear. It is translated. The rewrite is not a cure. It is a delay, because the problem was never the codebase. It was the physics. Technical debt is inevitable. Why? Because code volume grows linearly. Interaction complexity grows non-linearly. Teams grow, fragment, rotate. Context is lost faster than it can be documented. Abstractions leak, boundaries erode, and every temporary interface becomes permanent. Technical debt is not a mistake. It is the shadow cast by progress. We tell ourselves that we are building cathedrals, finished, timeless, clean. But we are not. We are tending gardens, planted in haste, shaped by seasons, constantly fighting what grows when we are not looking. A healthy system looks calm from a distance, straight rows, predictable paths, everything where you expect it to be. But growth never stops. Weeds spread underground before they appear on the surface. You don't finish a garden. You prune it. You rotate crops. You pull weeds. And sometimes you let parts of it die so that the rest can survive. Velocity at all costs is a lie that says if we move fast enough, the garden won't overgrow. It will. And if you don't plan time to tend it, the garden will reclaim itself. It will choose when things break, which paths disappear, which people burn out. That's what technical debt really is. Not a bug, not a failure of discipline. It's unattended growth. Stop asking, how can you eliminate technical debt? You can't. The only real choice is this. Do you garden deliberately? Or do you wait until everything is choking and call it a surprise? Pay the cost in small, intentional cuts today, or pay it all at once tomorrow in outages, rewrites, and the people who finally walk away. Technical debt is not a technical problem. It's the cost of growth. And growth, unmanaged, always takes more than it gives. Next, we'll examine AI accelerated technical debt. The incentives don't change, the interest rate does. If you want to see where this goes, subscribe to be notified when it's released.